So soon to be a good afternoon to everyone. And now it is my absolute pleasure to introduce you to Emilio.
Thank you. Thank you. Let's see. Can you hear me? Good. All right. I think good morning, good afternoon, good evening, depending which time zone you are. Let me start with today I'm going to present a tool called CIRCO. So let me first do some introductions. Hello, that's me. So I come from Japan. I know that I don't look very Japanese yet, but I've been living there for 10 years. So you can call me either way. It works both ways, Emilio, or something like that. I like to play with networks, packets, and a bit of 3D printing as well. So I did demo a few tools already in a couple of conferences. Some of them are in Japan, so you may be aware or not. And just keep in mind, I'm not a programmer. So the code works, it's nice, and there's a lot of improvement to do. But it runs. As long as it runs, we're good to go. All right, for those you are not familiar, what is actually the tool itself? The idea born actually from the automations. We have within enterprise networks, we have a lot of automations tools, and those tools actually are just discovering every new device that connects to the network and actually connect it and provisioning and do a lot of really cool stuff. Sure, but what about if it's not the Cisco switch what you are connecting to? They're basically giving us the credentials for free. Great, that was a good idea, I thought. So what it came out actually was a way to make something camouflage, which is not going to be noticed, and put it in the, when you do red teaming, within meeting rooms, open space, secretary, those kind of places. So I look into find a way to do this. So in this release 1.5, what is new is actually before releases, I was not able to have an IP phone working, so I will go and unplug the IP phone and use that cable, but that's it. The IP phone will be off. And that's something that people will notice because either it's not working anymore, and I wasn't very comfortable. So few people pointed out as well. So this version I managed to remove the phone, but plug the phone back to the box itself, and it keep working as it's nothing. So we're going to dig into that. I did some coding updates and also add some exfiltration techniques and encryption for prevent forensic, self-destroy switches, integration with Faraday, and bypass NAC, basically. A lot of features, basically, between 1.4 to 1.5. So who do we target? Well, pretty much any automation system out there. These are quite of a few known systems. HPNA is very popular. Of course, NetMRI as well. NAC itself is not an automation system for network provisioning, but what it does is try to prevent things that I'm trying to do, basically. So I will get rid of NAC as well. And of course, there's always some admin connecting to things that trust and put password everywhere. This is an example of things that happen with a Raspberry Pi. Some device in the network that nobody noticed, being exfiltrating data in the NSA. And this is not uncommon because NAC is very hard to solve all our problems. So it did happen. Okay, so what are my main issues for version 1.5? Power options. I'm going to put a Raspberry Pi, which I need power. Okay, battery, PoE. IP phone, when unplugged, that looks suspicious. Someone told me about if you find the little enclosure and you open, you can see the keys where the box is exfiltrating data, because it's just an SD card and a Linux. Yes, so I need to add some prevent forensics on it, encryption basically, which is a key, always a problem. All right, so let's start with the first problem, that is the power. So I came out with the paper idea. That's the easiest one. You just start to drawing things and come up with a list of wishes that you want to do. So this concept was, okay, the PoE negotiation is very complicated, and there's many standards, and there's many different ways to do it. Many implementations are different. But there's one thing, one element, that the phone and the switch, they will do the negotiation of the power. How much power you need, how many watts, etc., etc. So I didn't want to get into that. So I say, okay, let the phone negotiate. Once that's done, I just hook the power. So it came up with an idea that violates every principle in networking, pretty much. Okay, why not? Let's give it a try. So once you have a paper idea, what you tend to do is breadboarding. Let's go. Come on, plug some cables and see what happens. Something will blow up for sure. So you start to build up some ports, and yeah, this break all network industry standards, by the way. So trust me on that one. So what tends to happen when you start to do this is at some point, without you noticing, this actually works. And I'm like, okay, this is actually a good thing. So now you actually elaborate on it. So you move into prototyping. So this is a little board for just because they keep coming out, the jumpers from the breadboard. So you say, okay, let's make it a bit more stable. So I did a prototype to see, basically it's 4 RJ45 and a DC to DC converter plus a USB socket. So it was a very simple idea. It's all the wiring, the thing that goes underneath. So again, I never designed a PCB, so it would be nice to have like a Raspberry hat maybe, or go into that. So I'm still trying to figure out. For prototyping is okay. All right, how CIRCO evolved between different releases. So CIRCO has around 1 year old, maybe, around October 2018. So it started like an idea in a box. When I mean in a box, I mean literally in a cardboard box. It was good because you can see the components and you can see, this is this, and you can even put labels on it. So it was quite, yeah, it was fun. So what happened here is that I used to use a PoE LAN modules, and I bought one that is, so basically what it does is it does the PoE negotiation and then give you the LAN back and the power. So I bought one, 12 volts, okay, I need to convert this to 5 volts, and then I figured out they sell the 5 volts. So this is the first release, right? So then we evolved into a production. So you say, okay, let's move on. So I got some enclosures. They look like these boxes that you have under your desk, over your desk. So the whole concept is, okay, let's work with what we have in the market. So I look for these enclosures to put stuff in it. So in this release, I only have, you see there's only one cable going on. That's because I did unplug the phone and that's it. And also the smaller version. That was a bit more tricky because there's less space, but you can use a Raspberry Pi Zero, which is it's a bit cool, but you really need to work with the space. Again, this version has only one LAN. So you need to work with the LAN adapters on the Raspberry Pi. Right, so we move to this version. This version is actually this box. This box because remember, now I'm still in the phone, and I'm going to plug back the phone here. So what I'm going to do is use 2 different LAN adapters on a Raspberry Pi. So that's the reason I have a USB LAN adapter plus the onboard. As well, there is on the bottom, you will see a DC-DC converter, the 48 volts of PoE back to 5 volts to power the Raspberry Pi. And on the yellow thing that you may see there, that's actually a magnet switch. It's I 3D print some handles to mount it, but it's basically a magnet and a magnet switch. So what it does, that is the killer. When you open the case, it will detect that you open it, and you can RM, RFF, you can do whatever you want, reboot, shut down. So this is to prevent forensic in case some forensic don't unplug the cables and just open the suspicious case that they found. It will blow up basically if you want to. That was a bit dangerous to do. EPMs, heat ups, fire hazards. So just be careful. Of course, the same thing into the smaller box as well. Is here what I need to do is 2 USB LAN adapters and a hub. So it gets tricky, but it still fit. So depending what you find in the market as a discussed box, you can play around. So how much this costs? Because this must be a really expensive thing. Well, this is an example of how this box costs, right? So to give you an idea, this is a Raspberry Pi Zero. The 2 USB LAN adapters, the USB, micro USB hub are like ridiculously small. And just the outlet, which is one of the things more expensive, the outlet I think is $10 or something. So yeah, you can get this for $50. So if you don't want to go to pick it up, so you do a pen testing, you leave it there, you are welcome to go and pick it up or no. Depends how well things finish on the pen testing report, right? So, just in case you want to lose it. All right, so the hardware is one thing. It's very simple components. It's LAN adapters, Raspberry Pi, plastic box, and some DC-DC buckets. So now the question is what we are using as a software. Well, CIRCO is actually the little box, but we also have a few components. We have a component called CARPA, which is actually a software component only, running on the internet, in a VPS, Python, and Linux. That's very simple components. So that's software only. Why? Because once this box is infiltrated into the network, what is going to do? Well, it's going to become a Cisco switch to get discovered. So all these are lovely automation systems will connect to me and give me the credentials. So essentially, it's a honeypot, basically. But what happens once I have the credentials? SNMP, Telnet, SSH, whatever they use, sent to me. Great, now I need to exfiltrate to the internet. And this is the tricky part, because I need something on the internet to receive it. And that was CARPA coming to play. At the moment, I have a demo here, which I run it on a Raspberry Pi Linux. You can run it anywhere in any VPS in internet, Amazon, or any VPS server will do. The only requirement is that you have a domain name assigned to NS records assigned to this public IP of your VPS, or NATed if you have a NATed. So, and then we have one more component, which is Howla. Howla is, again, software component. You can run it on the Raspberry Pi with a power bank and a wireless adapter. What it does is basically you can also exfiltrate via wireless. So it will do from the box itself to the internet or via wireless, or both if you want to. But the via wireless, of course, you need to be in proximity. Keep in mind here, we are not setting up any access point. This is not an access point because that will be catched by a WIPS, right? WIPS. So we don't want any WIPS to notice us. So currently it's in Python 2, coming into 3 soon. And it's all packet manipulation are mainly based in SCAPI, in Python. And we are using some other tools from a different combination of people as well. For example, for the OS Fuller, some part of the code of the OS Fuller to full NAC, effectively speaking. And what actually exfiltration we can use, we have ping, traceroute, NTP, HTTP, HTTPS, DNS, proxy, and wireless, of which all of these are atomic. Basically, nothing come back, ever. So from a firewall point of view, it's a timeout session, H out. So there's never a session in none of those protocols that I just mentioned, or established connection or anything back. So basically, the CARPA never sent anything back to me. And another new feature that came out is just because I have a phone, right, and the phones keep working, I'm basically manning the middle between the phone and the network. However, most of the offices, people connect the phone and the PC to the phone. So that automatically gives me free traffic from the PC as well. So that was a free bug, kind of. So effectively speaking, you can run different tools to capture Telnet, SSH, FTP, so unencrypted protocols or hashes, and exfiltrate it as well. So not just the network part, but also the PC, if any, connected to it. So how I become a Cisco switch? Well, I need to be able to send a CDP, LLDPs. I need to be able to have an SNMP server agent basically running, and Telnet, and SSH, and all my packets need to look like a Cisco switch. So that was the triage basically of how we come out. So for flows, I have the single mode that used to be when you don't connect the phone back, and the bridge mode, which is the most interesting for this talk. So in bridge mode, this is how it will work, the logic, right? So once you turn this box on, what it does is does the discovery first to see what is the switch that is close to me, the real switch, and try to get the name. Once you get the name, he will try to get one similar to itself. So if this switch, for example, is switch Tokyo 01, he will become 03, or it will change the last digit by 2. The logic is very simple. If not, there are always a fallback to test 01. We need to pretend to be a nice new brand Cisco switch in the network. So we want to get that information first, then we get an IP address, and we start to set it up. Of course, the MAC address, it is of the Cisco switch. We changed MAC address at the beginning. As well, one thing we want to do is start to advertise CDP and LLDP to the switch. That's the way we get discovered with the automations tool. What tends to happen is the existing production switch is already hooked to automations tool, and when he sees CDP and LLDP new neighborhoods, he will discover that on the system, and the system once a day will connect and try to pull the config, etc., basically give us the credentials. So once this happens, once we get the credentials, we can set it up to how often we want to exfiltrate it. So I will cycle if you want to just do it once, or do it every 1 hour, the same exfiltration, and which method you want, all of them. So to do this demo, I actually need to build a network with a proper switch and a firewall and a router and a DHCP and the internet. And so I used to have all this spread in the desk. It was very difficult to set it up. You always forget one cable and things don't work. So because in Japan, we have a Toyota that make cars, right? So it came out with macaroni. This is our infrastructure in a box, basically, so in a briefcase. And it only costs $200. It doesn't cost 28 grand like Toyota. But what it does is simplify things very much. And so the lab itself, I know everything has an acronym, right? It match perfectly. So the lab itself looked like this. It's basically a proper Cisco. You can look it up after if you want to. It's a proper Cisco switch, and the CarPi is emulated with a Raspberry Pi. I also hook a snort in the outside on the internet to see what a snort will see. This snort is configured as a cam in the middle, like there's no actually any tuning. So it's default, basically, all. So it's supposed to catch even rubbish traffic as well. So what I'm going to do is explain how the exfiltration technique works. So for exfiltration, what I'm doing, I need to be able to tell my device in the internet these credentials, who took it from. So it came from my telnet daemon, my SSH daemon, through NCNP, or even the PC that was hooked. It's optional work I'm working. Also, I want to know that this is enabled password of the switch, or is the user and password of the switch, and is SNMP the community of, basically. This work with SNMP 1, 2, V2 as well. 3, not yet. But nobody used to actually in any network that I'm aware. But so this is the format and the source IP of the either automation tool or the laptop administrator, whoever connect to my box. Right. This is specifically the format that we want to exfiltrate. So one way to exfiltrate this data is, first of all, we will encrypt it with AES-256. So let me first go into Showtime. Let's start with the demo. Let me see if you can see that. Let me close this. So I cannot see though. I cannot see what I'm typing. Let me bring back. Can I mirror? I don't know how to do this. Look better now? Look okay? Yep? All right. So this is my server in the internet. So when I run it, I just this give me the options of the server. So this is my snort. This is my administrator PC. And what I need now is my box. I also have, this is because this version integrates with Faraday. So let me log in. So Faraday, I have one workspace, and I have hosts. I only have one host with some vulnerabilities, etc. All right, so let me do the magic. I do need to put a magnet because I opened the lid. So I need to, hack the lid open type of thing. So the phone is currently working. So what you do is you take the phone out. This is my LAN from the switch. So you plug it on LAN. And now I plug in an extra cable from the phone to the actual phone. Play it right. And there's a lot of flashing light here. But that is just in a Raspberry Pi, nothing more interesting than that. So one thing that I did find out was how to prevent encryption. So I'm going to use Lux to encrypt the partition where I'm going to have the software here in case someone found it. The problem with encryption is to decrypt, to encrypt and decrypt, you need a key. So what happens with it when you want to do that in a box that is already closed? You go there and put it. You don't have a laptop and installation system to spend or put a keyboard to a Raspberry or whatever. So what I came up with is I need a long key that I can use quickly to mount and encrypt this Raspberry Pi. So I found that this Raspberry Pi has Bluetooth. Great. So I create there's a million of applications. There's a Bluetooth application that you can create the services. You can do it from a Linux as well. So what I'm doing is I'm creating a service called CIRCO, and it has the UUID, which is 128 bits. So guess what? That's my key. So what this guy is doing, once he boot up, at the moment it's in demo mode, so I should be able to access. So if I do the F, the home drive that I want to do is called P encrypt. So if I do, there's nothing because it's not mounted, right? So what I'm going to do is turn on these Bluetooth services. It's a demo key, in case you are sniffing Bluetooth. It's not for production use, right? So once I turn on, it runs every 5 seconds, I think I put it, or 10 seconds. What it does basically is scanning to see if it found these services and use that key to mount and decrypt Lux. So ideally, this is all automatically, actually. So let me see. I think it's 10 seconds run every 30 seconds, 10 seconds. I can't remember where I put it. So I create the services. User system Lux. Yeah, I create a little script basically to do that. Let me see, this is on. Oh, maybe I have Bluetooth off. I will explain. There you go. No way it's jamming Bluetooth, right? Yeah, there you go. This is what happened with live demos. Come on. It's not coming. It did work before. Yes. Let me start. And let me do start. Maybe it's my phone. I think it's my phone actually. All right, I see. Restart. Nope. Unless I have the wrong key. Hopefully not. All right. Let me do this manually. Let me create this. Oops. Oh, it did work. Oh, it was already mounted. Yeah. Well, playing with Bluetooth within DEF CON sometimes is not a good idea. So let me turn off this back off. Right? It's already mounted. So let me go to, this normally will start automatically, but so, oops. So just to give you the menu. So I have CARPA, which is the one in the internet to receive the credentials, which I'm going to start in verbose mode. And the plugin is a Faraday plugin. And the interface is 0, and just a file where you want to put the output, the credentials you find. And so this is the CIRCO interface. So what you do, first of all, we go into bridge mode. Well, I put verbose. We go into bridge mode because it's the one using the phone and the LAN at the same time. You still have backward compatibility because that's a good way to do things. And then we can choose what exfiltration technique we wanted. You can choose either all, or can you ping, DNS, HTTP, web, NTP, proxy, I don't know, and tracer. I could put -A actually. So when you start it, let me see, this one already start. I'm logging into Faraday, okay. The plugin to Faraday, what it does basically is every credential that he will inject it into Faraday directly. So when the CIRCO starts in verbose mode, that's the reason you see all the steps that what it's doing. So start becoming a Cisco MAC address switch. This is to bypass NAC. Due to the MAC address I'm using, it's a golden one. So if you read through NAC, fork out NAC manual, there's a very small syntax that says, if you use this MAC address, you always allow it. Just read the document. Should be fine, right? Guess what? That's what I'm using. Great. Thank you for the manual. So become can you read, right? Yes? So you know I can make it bigger. That's too big? Better? Yeah? So what it does is, you become a switch, become a MAC address switch, discover, start the ECP, configure the interface. So this is all the configuration proxy. The proxy, I have 3 different techniques for the proxy. We'll go into details. This one is using the ACP. And then from here onwards, it started a honeypot, right? The last line you see is because the magnet I put there. The lid is open, but I put a magnet manually. So if I take that magnet out, things will go crazy. So now, I'm going to go to the real switch. This is my real switch, right? This is Tokyo 01, is my real switch. If I do show CDP, neighbors, guess what? I see a phone, and I also see a switch called 03, C2960. You can choose details. And this is, it has an IP address, this is a version, the port, it's a Cisco switch. So I can show CDP and show LLDP. As well, I can see LLDP. So this switch, is someone connected a new switch, maybe in a meeting room for a training or something. So it does has an IP address, which is 151, all right? So this is my admin PC. What happens if I telnet that IP address? I get the same prompt. Okay, so I tap my super user and switch number 3. So now I'm in what I believe is a switch. I can run commands, Cisco commands, show version, yep, it's a 2960. This is the version running. Show IP route, show IP ARP, show MAC address, show interface description. It is a Cisco switch, what I believe it. Show CDP neighbors. I need to type it correctly, of course, it's a Cisco switch. Yeah, I can see now Cisco switch 1, the production one. So they see each other, in theory. Same with the show LLDP neighbors. Yeah, I can see. So from this switch, so when automation systems connect to this switch, either by telnet or SSH, with the master credentials, they will run a set of commands to get the configuration, inventory, etc., etc. So those are most of the commands that support. I did not code the whole iOS simulator just for fun. It wasn't fun. Yeah, the question mark also worked, by the way. Yeah, oh, and if you want to go to show run, of course, you need to be enable mode. Okay, go enable. Yes, sure. Great, secret. Now I can do show run. Yeah, that works. What I can do is conft. No, that doesn't work. That's a common stack errors because I'm not going to prepare an iOS, basically, right? So this was a telnet I did, right? So you can see in the configuration that the community is public, the SNMP community. Now, what tends to happen is automation systems will first try their own SNMP community, and if fail, it will try the public, one of the list of the common ones. So let's say I will try the system community, the one that they use in the company, right? So when I try that will not work. A, because it's public, the one that works. But you did already give in the community with that command. So when you do public, it does reply like a Cisco switch. It is actually a name, the uptime, the version. It is a full SNMP device that you can pull. Now, what happened when I went back to CARPA? Well, I start to receive this data. This is because it's verbose. So basically tell me that something via ping from this public IP, telnet, user net admin, password, defcon, very smart, from this source IP they connect, which is the internal IP of this administrator laptop automation system. And then I get the same password via ping, DNS, traceroute. PDNS is proxy, by the way, HTTP, NTP, and then I also get this via here. So, oops, someone connect telnet, enable, the E just stand by enable with this super secret password. So again, if I now do the same thing, let me open the, so this is what this LIPS is looking. Ignore the unreachable because I don't have internet connection, of course. But the only traffic that these guys can see, because I enable the default, is a ping. So a Cisco switch is sending a packet ping. Nothing come back, but that's the only alarm, which I don't know anyone that has a snort with IC ping configured for alarms. That would be quite a lot of alarms. That's the only thing you can see on the snort side. So again, when you see a P and the community, my switch did not reply to the community, but you did give it to me. It did reply to public, but not to the community you give me, but I exfiltrated. So now if I go to Faraday, right? So when I do host, when I do refresh, now I have a new extra host. This 10.10.10.88 is the source IP of the automation tool or administrator, whoever is connecting. So what happens is if I go to the credentials, I can see the target, I can see the protocol. This comes to telnet, the enable, and the password. This is the telnet, the username, and the password. And this is SNMP. I should put SNMP instead of P. But so now, as soon as I get them in CARPA, via an API, I can inject it in Faraday in real time. So that's for helping the pen testing report side. So now, what happens if I actually remove the magnet? Careful. So you start to see this alarm open. That means that because I did not unplug it, right? I removed the magnet. So what it does is when it detects that someone opened the case, the magnet get open, it will send a magic packet via exfiltration saying that someone opened it. So, maybe they are ready, it's time to make the report. So of course, you can make it if you go here, for example. This was the CIRCO running in debug mode, right? So you see that it's sending the credentials, and here is when I took the magnet off, right? You can do this, for example. That command, what it does is immediately reboot. So what it does, remember, because we have the Bluetooth encryption. So unless I'm back close to this box with this thing enabled, that will not work if you reboot. So if someone unplug it and replug it, it will not mount encryption. So that is a balance between having encryption and functionality. So if you want encryption, you want the Bluetooth, sure. But if someone by mistake unplug and replug it, it will not work again. You need to be back, walking around with a mobile in your pocket, right? So yeah, you can do whatever you want. You can, eat PGM pulls, I don't know, burn fires, whatever you like it there. So this is the way that this stuff works. So these are the components. So let me go deep into the exfiltration. Something's in the middle, right? Excuse me. Oh, there you go. Go away. All right, so how I do, so this is basically a nice honeypot. Now, how do I take the data out? That's the interesting point. So this is going back to basics. So we are using protocols that are through firewalls. Some of them are blocking the companies, some of them can go through. So for example, some companies do allow ping to go for troubleshooting or trace route. So these are the protocols I'm using. ICMP, I'm using specific TCP and IP and UDP packets fields to actually put my data. Remember, I have one line, say T dash the comma, username, comma, password, comma, and IP address. That, what I do is encrypt it, AES-256, and now chunk it in 2 bytes or 6 bytes. So the way to work encryption, basically to decrypt it, you need to tell me how many packets I should expect, how long should my crypto be. So I'm going to send you 13 bytes of crypto in 7 packets. 2 bytes each. So first of all, I need to be able to tell that in advance before sending the packets. So what I'm doing is I'm sending 1 packet. These are the IP header. There's a field called identification in IP packets that do not get changed by NAT. When you NAT through a firewall, that doesn't get changed. So okay, it's 2 bytes that I can use for something. ICMP packets. Within the ICMP packet, you also have identification and sequence numbers. Again, 2 and 2 bytes that I can use for something. So ICMP, how it works, basically, I need to tell you my 13 bytes and 7 packets. So I will send one packet saying that 213 is the IP ID, right? And the rest is just randoms. So that means that the receiver knows that it's expecting 13 bytes, right? Then I'm going to send you 307 as an IP ID. 300 means that actually you are expecting 7 packets, right? And then I will send you 7 packets, right? With the 501, 502 as a sequence ID. That is the sequence of the packet, in case they get the different order arrive, right? And the crypto, within the ICMP sequence, which is 2 bytes, I will get that become an integer, and that will be my crypto. So I need 7 packets to do 13 bytes, plus padding, right? One byte of padding. So this is a way that most of the exfiltration technique works. It's basically chunking data into specific fields within different protocols, like ping, for example, or traceroute. Traceroute, we are using the data payload. For Cisco switch, the last 4 bytes are rubbish. So we are using those 4 bytes with X. My encrypted data become X. So I encode it into X, so it looks like an hexadecimal string. So that's a good place to put 4 bytes. Again, similar concept. First, I need to tell you I'm sending 30 bytes and 7 packets, and then I send you 1 by 1. Now, if we move into HTTP or HTTPS, remember, I'm not making a session. I'm just merely sending the SYN packet. That's it. So there's something called window size in TCP, and do not change between the client and the server through NAT. So you have NAT, and that thing doesn't change. Great. So I have 1-2 bytes that I can use that does not change between an internal client and an internet server. So that's what I'm using. Similar concept I'm using there, send it 213, and like we saw in ICMP, but I'm putting the crypto within the window size of the TCP packet. So yeah, port 80, 443, or any port you like, 25 if you want to. But remember, most of the stuff probably don't have direct access to the internet. So those exfiltration may not work. HTTP, HTTPS, actually any TCP port will be the same concept on this, right? You just send the SYN, nothing come back, and in the crypto goes into the window size. Of course, I become an integer, right? It's just supposed to be a number. So from X, I converted it in an integer. And the whole process is in reverse in the other side. In the CARPA, is the other side receiving, is the whole thing the other way around. So NTP was a bit fun. There's something called transmission timestamp, right? So the transmission timestamp has this format. So it's basically a timestamp plus a fraction. And the timestamp is 32 bits, and the fraction is 32 bits. Wait a minute, that's a lot of data I can put there in the 32 bits, I say. So I'm using the fraction. So basically the way that works is I'm playing with the stratum and pole to tell the entity, again, my crypto is 13 bytes, and it will send 7 packet or 6 packet or whatever is the padding that I need to do. In this case, I can send 4 bytes. So in reality, I don't need 7 packet because it's 13 bytes. So maybe 4 packets will do. So I need to tell them that it's 4 packets for this protocol specifically. And then I put it in the fraction, convert it into an integer, or actually it's a float because it's 32 bits. And then the process the other way. So inside the NTP query, I'm putting the fraction timestamp of the transmission timestamp, 32 bits of it. DNS packet, this one is easy. It just uses subdomain, encrypted.mydomain.com. But I'm not sending a query to the internet. I'm sending an NS query to the actually internal DNS on the company. So this attack is not direct. So I don't have access to go outside. But the DNS server has internet resolution through a relay or direct maybe. So what it tends to happen when you do an NS query, what it does, you will do recursive until you get it, assuming your DNS actually has internet resolution. Again, this is a hash encrypted. It's 20 bytes, 13 bytes we talk, so it's not very long char. You send it one query. Here is you don't need multiple. So in this case, is the flow of the thing. You will send just to the DNS server, internal DNS server, and the DNS server will go just directly to the. The trick here is that NS server should be CARPA, the IP address, the public IP, of course, of that evil domain that you're using. Now, what happens when the company do not have DNS resolution as well? No access to internet in any protocol, no DNS resolution, external DNS resolution. All right, proxy. They must have something. So proxy works in a way, how you discover proxy? Well, through how you set it up in PC's proxy. DHCP option 252, WAP, or GPO. Those are the three main, or manually, but I don't think people do that anymore. Those are the three most common. Okay, so what I do for DHCP, I will do a DHCP inform to the DHCP server to see if that option 252 is there and get the pack file. What you get is actually a pack file server, right? URL. Get there, connect, get the pack file, parse it to get the proxy IP and port, then connect to the proxy, right? And of course, all proxies are most likely authenticated. Doesn't matter. This doesn't need authenticate to the proxy to work. So this is a bit tricky because this unfortunately works with all Blue Coats, McAfee's, all the high-end proxies, because they forgot about something. When I do a telnet, a simple telnet to a proxy, and I do a get HTTP my crypto put dot my domain, and of course I do enter, and I get a 403, right, from the proxy. However, the proxy will generate the log in the system saying this IP address tried to go to this URL and he got a 403. But a proxy does one more thing. he does an NS query of that URL to put it log, the IP, which there's no IP. But what that means is he, which has DNS resolution, now is querying my DNS server with the string that I want to send. So he's, okay, thank you. That will do. So yes, it does generate one entry of 403 in a proxy logs. You know how many of those you get in a proxy constantly? Millions. So yeah, great. That works if we have the ACP option 252. Okay, sometimes you have WAP, if you still have WAP. Similar concept, I just will look for the WAP DNS entry, connect to the pack file, get the proxy, and do all over again. But again, no DHCP, no WAP, so most likely GPO. So the last thing I can do is DNS guessing. Basically, you give an array of names, like keywords, internet, or gateway, or GW, or PRX, or proxy, or gateway something. So you do that list of 10, 15 words, and I will generate a dictionary with a dash, with an underscore, backward and forwards. A matrix. And I will generate a list of 12, we'll say maybe 280. And then I will try with the DNS internal which one actually replied back to me. Then I will test, is this a proxy, a pack file server? So I will try to connect and try to get a pack file. Could be something else. If it doesn't work, I will keep trying until I see something. So this is the way to go around the GPO. Because GPOs, you need to have access to a Windows to actually see them. They're not being, it's per profile basically, so you can't really sniff it out the network. And the last thing is the wireless. For wireless exfiltration, remember I said I'm not setting up a wireless access point. I'm using beacons, very short beacons of 500 milliseconds. So what I'm doing is, within the beacons, I'm using the SSID names of the wireless at home and in many places. Normally tend to have like an X address, the last 6 digits of the MAC address of that home router is on the name of the wireless SSID. So I'm taking the opportunity to mirror that and broadcasting, but instead of MAC address, part of my crypto. So again, I have a 13 byte, I will chop it in 3, I will have 6, 6, and 1, we'll get padding, and then broadcast for 500 milliseconds that SSID of each of the 3. And the receiver will be looking for who is, it's like a phone broadcasting SSIDs for a very short time of period. So that's the reason WIPs will not see it. Basically, I'm using beacons as a back channel to push data out for credentials. And that's it, what I have. Questions? Or no? Can you defeat MACsec? But the thing is, when you connect the switch, right, what you have is actually a phone connected to the switch. So most NAC systems, or if you like, you want to have a network with one MAC address allowed only. Well, most of the company has a phone. The phone tend to have a PC after. So you need at least 2, minimum, right? So because you are putting a Cisco switch and the MAC address that, well, a Raspberry Pi, the MAC address I'm using is actually a golden MAC. NAC cannot block that one. Because the trick is very simple. There's a MAC address for virtual like HSRP or VRRP services. Cisco HSRP is a routing stamp gateway, right? So what it does is they have virtual MAC address that they create. Those virtual MAC address are whitelisted by default in all NACs, based on the documentation. I did not write it. So I'm using one of those. Any other question? Yeah, where? This one? Ah, sorry. Yeah, I will release the version after DEF CON. No time over DEF CON, it's procrastination, but I will push it out to GitHub, the newest version, and the guide for the building. Well, building is, to be honest, quite straightforward to. Usually doesn't require to be electronics to do that. It's just a Raspberry Pi and a few things. But, and the presentation, I believe the slides will be up soon. We'll put it in the website as well. There's a website somewhere? Yeah. There's stickers on the back, if someone wants stickers. If not, let me know. I still have some stickers. If no more questions, thank you very much for listening.